This last section, we'll take a look at the domain and range of quadratic functions and maximum and minimum values. Finding the domain and range of a quadratic function from a graph is pretty easy. So the domain, remember, of a quadratic function is always all real numbers. There's no restrictions on the domain of a quadratic function. The range is pretty easy too. To find the range, first you look at the vertex. So here's an example of a parabola whose vertex is at 2, 1. Now remember, what is the range? The range is the set of y values. And you read it starting from lowest to highest. So this function has y values that start at 1 and then keep on going. So the range would be the interval from 1 to infinity. And that's all there is to it. Let's try another example. Find the domain and range of this quadratic function. So the domain is always a set of all real numbers, and for the range, we're going to start by thinking about the vertex. So this vertex has coordinates -3, 2. And when you think about the range of a function, you think about the y values starting from lowest to highest. So we see that the y values start at -infinity and they go up to 2. So the range of this function would be from -infinity to 2. So finding domain and range from a graph is really easy to do. What about if we're given the equation? Find the domain and range of f of x is equal to 3x minus 2 squared minus 5. Well, what I would really suggest is just draw a quick sketch of the parabola. Because this is in standard form, we can clearly see the vertex. So remember, the vertex is the point h, k. And in standard form, this parabola would have a vertex at x minus h is 2, and then at the end we're tacking on a -5. So this parabola would have a vertex at 2, -5. Because a is positive, we know it's going to open upward. So that's a very rough sketch of what this parabola might look like. Domain, always the set of all real numbers. The range, again, we're going to key in on our vertex. Our vertex is the point 2, -5, and we're going to start on the y-axis and go from lowest to highest. So the range would be from -5 all the way to infinity. It's very easy to also find the maximum or minimum values of a quadratic function because they're found at the vertex. So this quadratic function would have a minimum value. The vertex is the point 2, 1. So we would say that the lowest value of this function, the lowest y coordinate, would be 1. And it occurs where x is equal to 2. So this function has a minimum value of 1 at x is equal to 2. Notice this function has a maximum value. So the coordinates of this vertex are -3, 2. So we would say that this function has a maximum value of 2. So that's the highest y coordinate you'll find on the graph. And it occurs where x is equal to -3. A maximum value of 2 at x is equal to -3. So why don't you try this one? Now remember, we already sketched a graph of this one just a minute ago. So look back in your notes and then use the graph that we sketched where we talked about the vertex of this parabola and see if you can find out whether this parabola has a maximum or a minimum value, what it is, and where it occurs. Finally, we're going to review the quadratic formula. So here's the quadratic formula. X is equal to the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. And what the quadratic formula does for us, it solves the function value where the function is equal to 0. In other words, it helps us find the x-intercepts, because the x-intercepts are the value of x for which the function value is equal to 0. Here's an example. Find the x-intercepts, if any, of f of x is equal to 3x squared minus 2x minus 4. Round off your answer to 1 decimal place. So we're going to go ahead and we're going to use the quadratic formula. A is equal to 3, b is equal to negative 2, c is equal to negative 4. b squared is negative 2 times negative 2, or 4. 4ac is 4 times 3 times negative 4, or in other words, negative 48. And 2a is 2 times 3, or 6. So whenever I do the quadratic formula, I always put my scratch work off to the side. And the reason I do that is because it makes simplifying the formula very easy for me, because when I simplify the formula, then I'm only substituting in 4 numbers. So the formula again looks like this. X is equal to the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. So if I do this scratch work, then all I have to do is say x is equal to the opposite of negative 2 plus or minus the square root of b squared is 4 minus 4ac is negative 48, that's plus 48, all divided by 2a, which is 6. In other words, 2 plus or minus the square root of 52, all divided by 6. If you've ever struggled with the quadratic formula, I think it's because no one ever taught you, or you never tried to do the scratch work off to the side. I see so many people struggle with the quadratic formula because what they do instead of scratch work is they try to just plug in all the numbers, and it just gets overwhelming. So they would write the opposite of negative 2 plus or minus the square root of negative 2 squared minus 4 times 3 times negative 4, all divided by 2 times 3. Can you see the difference between what I wrote and the formula if you plug in each number one at a time? So if you've ever struggled with the quadratic formula, try doing the scratch work and then just plugging in 4 numbers. It's so much easier. Of course, if you're very good at doing the quadratic formula without the scratch work, then of course stick with what you know. But anyhow, that's just a tip in case you've ever wondered about how you can get better at the formula. Now, the problem did say round off your answer to 1 decimal place. So why don't you go grab a calculator and put in 2 plus the square root of 52 divided by 6 and 2 minus the square root of 52 divided by 6, and write down what your 2 answers would be rounded off to 1 decimal place. Now, you may have wondered about this word, if any. We already know that not all quadratic functions have x-intercepts. For example, if the graph of the parabola looked like this, then the parabola is not going to have any x-intercepts. And you might wonder, well, how would you ever recognize that by using the quadratic formula? Well, if you had a case like this, when you use the quadratic formula, this is what would happen. You'd be going ahead, you'd be using the quadratic formula. What would happen when you tried to use the quadratic formula is that this expression right here, b squared minus 4ac, would be negative. In other words, you would be taking the square root of a negative number. Now you know that the square root of a negative number, there's no real number which is the square root of a negative number. We would have to use imaginary or complex numbers in order to simplify that. So if you're ever using the quadratic formula and you come up with a negative expression under the radical sign, what that tells you is that this quadratic that you're working with would have no x-intercepts.